Assalamualaikum and hi to all students. Today I would like to show to you how to balance the redox equation. At the end of this video, students should be able to write a balanced redox equation by ion-electron method. You may refer to your lecture notes for this video. Okay class, so you have this equation which is unbalanced equation. And in order to balance the equation, we need to read the question carefully whether the reaction occur in acidic solution or in basic solution. Alright, let's say I want to balance the equation where the reaction occur in acidic solution. Step 1. Write the unbalanced equation for the reaction in ionic form. Step number 2. Separate the equation into two half reactions. In order to separate the equation into two half reactions, you need to identify the species undergoes oxidation and the species undergoes reduction. Okay, by referring to the unbalanced equation given, in order to determine the species undergoes oxidation and reduction, we need to compare the oxidation number of the species. Let's say I would like to compare the oxidation number of iron. So, I will compare the oxidation number of iron 2 plus and iron 3 plus ion. So, this is one pair of half equation. And another one, I need to compare the oxidation number of chromium atom in dichromate ion and chromium atom in chromium 3 plus ion. So this is the second pair. Okay. In the first pair, where iron 2 plus converted to iron 3 plus, you can see the oxidation number of iron 2 plus is positive 2, while the oxidation number of iron 3 plus is positive 3. The oxidation number of iron increased. Therefore, we can say that the iron undergoes oxidation. So, I write here oxidation. Right. And now, let's see the second half equation. Okay, we need to compare the oxidation number of chromium atom in dichromate ion and chromium atom in chromium 3 plus ion. If you calculate the oxidation number of chromium atom in dichromate ion, you can see the oxidation number of chromium atom is positive 6. The chromium oxidation number in chromium ion is positive 3. So, oxidation number of chromium decrease, we can say that the chromium is the species that undergoes reduction. Right, so I rewrite the equation. So this is the half equation that represent oxidation process, and this is the equation that represent the reduction process. So this is the first step. The second step. Step number 3. You need to balance the atoms other than oxygen and hydrogen in each half reaction. Let's start with oxidation half equation. So, in this half equation, only iron present at the both sides. So, we don't have to add oxygen and hydrogen to balance the equation. So, the oxidation half equation is no change. But for reduction half equation, at the left side, we have 2 chromium atoms. But at the right side, only 1 chromium atoms present. Okay, so I need to put 2 mole of chromium ion 3 plus at the right side. Okay, next. Step number 4. Add water to balance oxygen atoms and hydrogen ion to balance hydrogen atoms. In half equation, oxidation reaction, we don't have to add water or hydrogen ion since there is no oxygen and hydrogen atom present. for the reduction Harvey equation, at the left side, in dichromium ion, there are 7 oxygen atoms. While at the right side, there is no hydrogen atom. So I need to balance the oxygen atom. How to balance the oxygen atom? I need to add 7 mole of water molecule. Because in 7 mole of water molecules, there are 7 oxygen atoms. But there is one problem here. Since I add 7 mole of water molecule at the right side, so there are 14 hydrogen atoms at the right side. But at the left side, there is no hydrogen atoms. So in order to balance the hydrogen atom, I need to add hydrogen ion, H+. So I need to put 14, I need to add 14 H+ at the left side. Okay, continue with the next step. Step number 5. Add electron to one side of each half reaction to balance the charges on the half reaction. Alright. In order to add the electron, we need to recall the knowledge about oxidation and reduction. Oxidation is the process where the species remove electron. Remove electron. The electron must be removed. The electron must be placed at the right side. But before I add electron at the right side, we need to check the balance at the left side first. So, iron 2 plus brings positive 2 charges. So, the total charges at the right side must be equals to positive 2. So, iron 3 plus brings positive 3 charges. One electron brings negative 1 charge. Alright, so how many moles of electron must be added here to get positive 2? So positive 3, if I put 1 electron here, positive 3 plus negative 1, it is equal to positive 2. So the total charges at both sides are balanced. Therefore, in oxidation half equation, 1 mole of electron is added to the right side. Alright, so now let's see the reduction half equation. Reduction half equation. The reduction process is the process where electron is added, or we can say that the species accept electron. Okay. Alright. So before we add electron at the left side, we need to check the total charges at the right side. So 2 times positive 3 equals to positive 6. 7 mole of water, overall charges is 0. You can see there is no charge here. So total, the overall charges of water molecules is equals to 0. So positive 6 plus 0 equals to positive 6. So the total charges at the left side must be equal to positive 6. 14 hydrogen ion, 14 H plus brings positive 14 charge. And 1 mole of dichromium ion brings negative 2 charge. Because 1 mole of dichromium ion times negative 2 equals to negative 2. So positive 14 minus 2 equals to positive 12. Positive 12 at how many moles of electron will be equals to positive 6? So if I put 6 mole of electron here, 14 mole of hydrogen ion brings positive 14 charge, minus 2 positive 12, positive 12 minus 6 is equals to positive 6. So 6 mole of electron are added here. So settle with step number 5. Step number 6. Balance the electron in the two half reactions by multiplying the half reactions by appropriate coefficient. If you compare both half equation, oxidation and reduction, the number of moles of electrons are unbalanced. Right? So in order to balance the electrons, the oxidation half equation, I need to multiply with 6 to get 6 mole of electron. So 6 is multiplied to the whole oxidation half equation. Therefore, I will write the new equation 6 mole of iron 2 plus converted to 6 mole of iron 3 plus 6 mole of electron. You can see the electrons are balanced for both half equation. Alright? Okay. Next step, step number 7. Add the two half reactions together and balance the final equation by inspection. The number of electrons on both sides must be equal. Alright, so this is the half equation for oxidation reaction. And this is the half reduction equation reaction. Alright, since the number of electrons are equal, we can cancel out 6 mole of electron in order to get the overall equation. So after that, rewrite the equation. Okay. 6 mole of iron 2 plus 14 mole of hydrogen ion plus 1 mole of dichromate ion produces 6 mole of iron 3 plus 2 mole of chromium 3 plus ion and 7 mole of water. Alright. Next, step number 8. Verify that the electron number of atoms and the charges are balanced. This is the overall equation. So check the number of atoms and check the total number of charges. So at the left side we have 14 hydrogen ion. At the left side we have 14 hydrogen. At the left side we have 7 chromium atom. At the left side we have 2 chromium atom. At the right side we have 2 chromium atom. At the left side we have 7 oxygen atom. At the right side we have 7 oxygen atom. At the left side we have 6 iron, and at the right side we have 6 iron. That is in terms of number of atoms. So now check the charges. The charges must be equal for both sides. So this one for positive 14 plus 1 times negative 2 is negative 2 plus 6 times positive 2 is equals to positive 12. So 14 minus 2 is equals to positive 12. Positive 12 plus positive 12 equals to positive 24. So now check the total charges at the right side. 6 times positive 3 equals to positive 18 plus 2 times positive 3 equals to positive 6 plus water, the charge is 0. So positive 18 plus positive 6 equals to positive 24. So this is the equation for a redox equation for acidic medium. The balance equation for redox equation which is occur in acidic solution. But what if the reaction occur in basic solution? You will do the same step 1 until step 8, but you need to continue with step number 9. For reaction in basic solution, add hydroxide ion OH- to both sides of the equation for every hydrogen ion that appears in the final equation. So this is the final equation balanced just now. Right. So please refer to the hydrogen ion present in this equation. We can see here we have 14H+. So if the reaction occur in basic solution, we need to add 14OH- at the left side plus 14OH- also at the right side. So 14OH- plus 14H+ is equal to 14 mole of water plus dichromate ion plus 6 mole of iron 2 plus produces 6 mole of iron 3 plus 2 mole of chromium 3 plus ion plus 7 mole of water plus 14 hydroxide ion. Okay, so in this equation, we have 14 mole of water at the left side and 7 mole of water at the right side. So we need to settle it because water cannot appear at both sides. So 14 mole of water minus 7 mole of water, it is equal to 7 mole of water molecule plus dichromate ion plus 6 mole of iron 2 plus ion produces 6 mole of iron 3 plus ion plus 2 mole of chromium 3 plus ion plus 14 hydroxide ion. Alright. So, check the equation whether the charges balance already, and same goes to the atoms. Alright, okay. So, 7 mole of water, the charge is 0. 1 mole of dichromate ion brings -2 charge. 6 mole of iron 2 plus ion brings positive 12 charge. So positive 12 minus 2 equals to positive 10. Right. At the left side, 6 mole of iron 3 plus ion brings positive 18 charge plus 2 mole of chromium 3 plus ion brings positive 6 charge, and 14 hydroxide ion brings negative 14 charge. So positive 18 plus positive 6 equals to positive 24. Positive 24 minus 14 equals to positive 10. So the charge is balanced at the both sides. Therefore, this is the balance equation if the reaction occur in basic solution. Alright class, so I hope this slide helps you. Okay, see you later.